The second section in Chapter 8 for hypothesis testing starts to talk about testing for means. So you're going to use sample averages and use those to make a claim about what is going in or and to test the claim about what's going on about your population proportion or your population average. So the second one in 8.4 is that we have 27 jelly beans and we take their average weight, and for whatever reason we know that the population standard deviation for jelly beans all over the world is 0.0565. If you have the sigma, you know the population standard deviation, then we're talking about something that we know for a fact is normally distributed. And so therefore we're going to be able to use these scores. We're going to use a 0.05 significance to test the claim that the mean weight of all the jelly beans is equal to a 0.8560. And we're going to assume, of course, that all these jelly beans are normally distributed. So what we're really looking at, and I did the whole problem out, we'll put it in MyMathLab so you can see what it looks like, is something that looks like this. I have my X bar, I have my N, and my sigma, and my alpha. These are the important pieces of the information. And I drew my normal deviation, my normal curve. I know that if I have an equal to and a not equal to, because I'm testing that this claim, this is my claim that all the jelly beans in the world will have an average weight of 0.8560. The opposite of my claim is that they won't. And when you have an equal and a not equal, you talk about two-tailed test. And since the error in the tails is 0.05 and a two-tailed test is always going to be symmetric, I have 0.025 in one and 0.025 in the other, which and 95% in between. So just like with the confidence intervals. First thing I'm going to do is run my test stat. I find my test stat by using x bar minus mu that I'm testing over the population standard deviation divided by the square root of n, and I get a very, very small z-score of 0.09. So I know that's going to land real close to the middle here. Now at that point, I either have to find the criticals or I have to compare p-values. I chose to find these critical values because sometimes MyMathLab will ask for it. If you want to know if it lands outside the goalpost or inside the goalpost, you got to know where the goalposts are. Well, the goalposts are set up so that this error over here will be 0.025. So I'm looking for the area under the z-score that is a 0.025. What z-score has that area? A negative 1.96. These z-scores, these critical values, when you have a two-tailed test, will always be opposite. So I didn't need to run a 0.975 to find out what that would be. I know that would be a 1.96. They're always going to be opposites when you have a two-tailed test. You really only need to find one. I know then for sure that this 0.09 lands in between these two in the green zone. So I know if I'm in the green zone, I keep my null, which means I'm going to fail to reject the null. Good news for me. There's sufficient evidence to support my claim, since the null was my claim. Now, had I chose to do this in my calculator, what I would do, and I'll pull it up at the same time, and I'll post that picture too, is I'm going to turn this mess on, maybe, and I'm going to go to stat, over to tests, and now use z-test, which is the very, very first one. You'll notice here that you'll have two options. You'll have stats and data. When they give you the information, when they give you the standard deviation, they give you the mean, you're going to use stats. If they give you a big list of data, well, then go figure, then you're going to use data. And you would move it over, and you would have to first put all of that data into list one. And we're going to do one of those for the t-scores in a few minutes. I put in my null, I put in my population standard deviation, I put in my average and my n. And of course, this guy is still going to match whatever is going on over here in my alternate. I had a not equal sign. When I run calculate, I get my p-value. My p-value is a 0.9267. 0.9267 is much bigger than this. If the p is high, then the null goes nowhere, because if the p is low, the null goes. So p is not low, the null does not go. And so I can use then my p-score, my p-value to say, oh, well, I failed to reject. And so those are those two screens that I had right there. So you can do it by hand or you can use your calculator. Either way is fine.